Alright, so today we'll be finding x coordinates, x and y intercepts, the critical point, open intervals where it's increasing, decreasing, the relative min and max, and whether it's concave up or concave down on points in the graph. So first we'll start out with finding the x-intercepts. So x-intercepts, you just plug this, make it equal 0. So you take out a 2x squared, so that'd be 2x squared, so that would be x plus 2. So your x-intercepts would be at 0 and negative 2. So that'd be here and then there. For y-intercepts, you just plug 0 in for x, so y-intercepts is just 0. Okay, and then critical points, you have to do the first derivative test. So for the first derivative test, it would be 6x squared plus 8x. And then you would solve that, set it equal to 0, solve for that, and then the critical points you come out with would be negative 4/3 and 0. And then to find whether it's increasing or decreasing, you have to find points on either side and in the middle of these 2 points on the graph. So we'll just do negative 4/3, 0, so that'd be 1, negative 1, and negative 2. And then you would plug these into the first derivative test equation, which we already did. So that would be 8, negative 2, and 14. Okay. So know if it's increasing or decreasing. Increasing is going from positive to negative. When it's negative to positive, it's decreasing. Other way around, flip that. So it's increasing from negative infinity. No, that's not infinity. Negative infinity to negative 4/3. It's increasing from 0 to infinity, and it would be decreasing from negative 4/3 to 0. Okay, so for min and max, to find the y-coordinate, you have to plug your critical points back into the original equation. So for 0, that'd just be 0, 0. And for negative 4/3, that would be 64 over 27. So that'd be negative 4/3, 64 over 7. Okay, so that would be at 0, 0. So it's going from positive to negative. So that means that's where the minimum of the graph is. And because it's going from, positive to negative, that means it's the max of the graph. So we throw these down on there. There. Okay, and then we have to do the second derivative test to find the inflection points. The inflection points is where it flips. So that would be 12x plus 8, which comes out to negative 2/3. So your inflection point would be at negative 2/3. And to find where it's concave up and concave down, you have to find points on either side of your inflection point to find if it's up or down. So we'll do 0 and negative 1, which comes out to, you plug these into the second derivative test, which comes out to negative 4 and 8. So now that you have these, you know that it is concave up from negative infinity to negative, I'm just gonna use this. So you know it's concave up from negative 2/3, or negative infinity. Sorry, I missed that. Negative infinity to negative 2/3. And it's con down from infinity, from negative 2/3. Negative 2/3 to infinity. Which, if you take all that information and put it up on a graph, would actually look something like this.